So in continuation with our previous lecture, in this lecture we would like to divide this isomerism into different types. First of all, you have seen isomerism can be broadly of two types. One is structural isomerism. One is structural isomerism. Another is stereoisomerism. Stereoisomerism. We'll not deal with this structural isomerism because you have studied it in your earlier classes. So we'll mostly study this stereoisomerism. Stereoisomerism can be divided into two types. One is known as configurational isomerism. And another is known as conformational isomerism. I will define these two terms, configuration and conformation. This configurational isomerism can be divided further into different types. It can be divided into cis-trans isomerism. As you have seen, I have given you examples, or it's also called as geometrical isomerism. It's also called as geometrical isomerism, and another type is known as optical isomerism. Okay, now this optical isomerism, it can be of two types. Optical isomers can be of two types. One type, they are known as enantiomers, and another type, they are known as distereomers. So this is a broad classification of isomerism. First, there are two types. One is structural isomerism, another is stereoisomerism. Stereoisomerism can be divided into two types. One is configurational isomerism, another is conformational isomerism. This configurational isomerism is further divided into two types: cis-trans isomerism or geometrical isomerism, and second one is optical isomerism. And this optical isomerism can be of two types. One is known as enantiomerism or enantiomers, and second one is known as distereomerism or distereomers, they are called as. First of all, I would like to throw light on what is the difference between a configuration and a conformation. Configuration is the three-dimensional arrangement of atoms or groups in space where one arrangement can be converted into another by not simple bond rotation, but by breaking the bonds. This is known as configuration. Example, I will take example of cis-2-butene and trans-2-butene. If you have to convert cis-2-butene into trans-2-butene, what you have to do, this is trans-2-butene, You can convert one arrangement of atoms into another by not by simple rotation about this carbon carbon double bond, because bond rotation around this carbon carbon double bond is not possible. It's not a single bond, it's not a sigma bond where bond rotation is possible. It's a double carbon carbon double bond. So what you have to do, you have to break the bond. So breaking of this bond converts one stereoisomer into another stereoisomer. Such isomers which are interconvertible by bond breakage and not by simple bond rotation, they are known as configurational isomers. So we'll define this configurational isomers as those stereoisomers which are interconvertible not by simple bond rotation but by bond breakage but by bond breakage. Such stereoisomers are known as, they are called as configurational isomers. इनको हम configurational isomers बोलते हैं. एक एग्जाम्पल मैंने दी आपको. अगर आपको दूसरी एग्जाम्पल चाहिए, here is another example for you. CH3 and CH2 CH3. This is H, this is Br, this is CH2 CH3, and this is CH3. These two are also stereoisomers, as I already mentioned. But if you want to convert this stereoisomer into another one, if you want to convert these stereoisomers into one another, what you have to do, simple bond rotation will not do the job. You have to break the bond. You have to break the bonds, or you have to break the bond. Then only by bond breakage can you convert one stereoisomer into another. Such isomers are known as configurational isomers. इनको हम configurational isomers बोलते हैं. Now another term is conformation. What is conformation? Or what are conformational isomers? What are conformational isomers? Conformational isomers are those stereoisomers, mind you, they are examples of stereoisomers, both configurational and conformational are stereoisomers which are interconvertible by simple bond rotation. ये जो स्टीरियोआइसोमर्स है, ये एक आइसोमर दूसरे में कन्वर्ट होता है बाय सिंपल बॉन्ड रोटेशन. एग्जाम्पल मैं लूँगा, सिंपल एग्जाम्पल ऑफ ईथेन मॉलिक्यूल CH3 I will take the simple example of ethane molecule, CH, 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 and CH. If we draw its Sahar's formula, you can show it like this. This ethane molecule, you can show it like this. This ethane molecule can have different, arrangement of atoms in space. You can show this molecule like this. This is the Sahar's formula for ethane molecule. And around this carbon-carbon single bond, the bond rotation is possible. Bond rotation is possible. So when bond rotation occurs, this methyl group can rotate with respect to this methyl group, and as a result this rotation can be shown by this Sahar's projection. It's known as Newman projection. It's not Sahar's, it's known as Newman's projection. It's known as Newman projection of ethane molecule. And you can see if we rotate it by some angle, let's say 60 degree. If you rotate it, we have another conformation, and that will be keep this constant. This one will keep this one constant, and we will rotate this. These hydrogens will rotate, which I am taking by after rotation. This will reach here. This hydrogen will reach here. Okay. This hydrogen will reach here, so I will draw it like this, and this hydrogen will reach somewhere here, so I will draw like this. So this conformation is known as staggered conformation. It's known as staggered conformation, and this one is known as eclipsed conformation. So there are also this staggered and eclipsed conformation. They are stereoisomers, but precisely they are known as, we call them as conformational isomers. Why? Because they can be converted into each other by simple bond rotation. सिंपल बॉन्ड रोटेशन से हमने इसको एक को कन्वर्ट किया दूसरे में, स्टैगर्ड को कन्वर्ट किया इक्लिप्सड में, या इक्लिप्सड को कन्वर्ट वापस किया स्टैगर्ड में. इनको हम बोलते हैं, दे आर नोन एज कन्फर्मेशनल आइसोमर्स.